Now we'll be taking these tube socket pin these tube pin voltages to ground. We'll be setting up our multimeter and measuring each of the pins to ground. I'm talking about the plate, the screen grid, and the cathode. Now why is that? Well, because it says here that when these voltages were taken on this little chart here, the tube socket voltages were measured to ground. And we have to do the same thing. We can do that. A while back, I had a couple of people contact me that were just starting out, and they said, what does it mean to take a voltage plate to ground? Or what does it mean to take a voltage cathode to ground? Well, in this radio right here, the chassis is ground. So I've got a gator wire connected to it, and I'm going to go ahead and hook my negative lead from my multimeter to it, and that'll give me my chassis ground connection. That's what I've been doing all along here. Now, I'm going to give you a little illustration to show you what it means to take voltages plate to ground, cathode to ground, screen grid to ground. Here's a tube, a 78, and I drew a little negative symbol down here, and we'll say the negative symbol is our chassis in this radio, and I've got the negative lead from the multimeter connected to it. Now if I take my positive lead and I go to pin 2, which is the plate, I'm now taking a voltage reading plate to ground. If I move my red positive lead over here to the cathode, which is pin 5 on this 78 tube, see the letter K right there, K for cathode, I'm now taking a voltage reading cathode to ground. The screen grid is pin 3, or G2, grid number 2 is what they call it. This would be the control grid, screen grid, suppressor grid. So the second one is the screen grid. If I touch it right here on the bottom of the tube socket, pin 3, I'm now taking my voltage reading screen grid to ground. Is that a piece of cake or what? Okay, we're ready to take our first tube pin reading. The 78 tube on the plate, pin 2, should have 245 volts. Now pin 2 would be, there's 1, and the one next to it is 2. We're going clockwise, starting between the two large pins. Pin 1, pin 2, pin 3, pin 4, pin 5, let me see, pin 1, 2, 3, 4, 5, 6. So let's go here to pin 1, pin 2, the plate. We should get 245 now. 317. Not good. Way high. Tell you what, let's take a plate voltage reading of the second 78 tube. It's also supposed to be 245. And that one would be way down here. And it would be this pin right up in there. I know you can't see that very well, but trust me, it's on pin 2. 322 volts. Supposed to be 245. That's not good. We definitely have a high voltage problem, a high B plus problem on the plates of the 278s and the 6A7 detector oscillator. The 75 was also high, but not quite as bad as these here. So I went through and I checked all the resistors, everything. I double checked everything I had done, and I came up with no problems. And I'll tell you the truth, I was at a loss. Why did I have such high voltage here? It wasn't the high voltage winding on the transformer. We already checked that out. In fact, it was 10 volts below what it should be, which is perfectly acceptable after a radio's been sitting around for this many years. So I decided to call my old buddy Norm Leal out in California. I got a hold of him and I said, Norm, what is going on? I've got everything fine. The radio plays fine. But when I went to check the plate voltages, they were way off by at least 70 volts too high. 75 volts too high. And I sent him a scan of this schematic, and I showed him all the voltage readings I had taken, where I had penciled them in with pencil. And he said, you know, John, he said, here's what it looks like to me. It looks to me like your 42 tube has low emission. He said that is the highest emission tube in the circuit, but I'll bet you it's low emission. And I'm thinking to myself, you know, what does the 40 tube low emission, possible low emission, have to do with the plate voltages on the other tubes? Well, do you all remember this from the last video? And we have 123.1. Ho, that's more than what we had before the resistor. Now how can that be? Well, I'll tell you. The power switch isn't on. We turn the power switch on the radio and watch what happens. There she drops down. What Norm was saying was that unless this 42 output tube is conducting to its maximum level, then it's not going to pull down the B+, just like you saw in the little segment I just showed you when I turned on the switch on the radio. When I turned that switch on in the radio, what happened was all these tubes began to conduct, and it pulled down the voltage. The same thing happens here on this 42. If it's not conducting, it doesn't pull down the B+ voltage that's being supplied to these plates of these tubes. So, now it makes sense to me. I think we better pull this tube out and run it across the tube tester and find out what kind of emission we're getting. I just stuck the 42 tube in the tube tester. I've got it all set up. Now when I pull this lever right here to value, I should get 1.3 to 2.5 on this bottom scale, or the second scale from the top. So we're talking about 1.3 right here up to about 2.5. So it should be in that range right there. So let's find out how much emission we have here. We're pulling the old lever and watch the needle. Ho ho ho! Very low, just barely hanging in there. Here's a new 42 tube that I just purchased from my tube man Gino out in Amarillo, Texas. He supplies all my tubes, and I can tell you already that we're going to get a better reading. Look how bright the filament is on that tube. The old tube was dull. It did not have that kind of a glow. So here we go. Remember, we need to get it between 13 and 25, which will be up in this area here. Let's see what we got this time. Look at that. Oh man, way up there. Way up there. Lots of good emission. Well, let's take a voltage reading now and see if our volts have come down from 317 or 320 with that new 42 tube in there. So we're going to take a reading of the pin 2 of the 78 tube right here. I've got my negative lead from the multimeter hooked to the chassis. That's my ground. Now we're going to go 1, pin 2. Let's see what our meter reads. 280. My God, we've come down, what, almost 40 volts. It's supposed to be 245. It reads 280. Big improvement so far. Alright, let's take a reading on the 6A7 tube, which will be down in there, pin 2. 279. Again, we've come down, way down. And we'll take a reading on the 78, the other 78 tube way down the bottom down here, see what that one reads. Again, 284, 283. Not bad. We've come down a long ways. Since we still have about 40 volts too much of B plus on those plates, I decided, why not just go ahead and check the rest of the tubes while I got it out, the tube checker out. So I checked the 278s. They're good. No problem on the 278s. And we're getting ready to check the 6A7 and the 75. So let's do the 6A7 first. Alright, the old 6A7 is in, and I've got everything set up the way it's supposed to be in accordance with the chart. And it says here, the 6A7, I should get 0.80 to 1.6. That would be 0.80, right about there, to 1.6, which would be right about up in there somewhere on the bottom scale, on the second scale. So let's hit the switch right here again. Let's see what happens. Ooh, barely makes it into the 0.8. Barely makes it. That tube is too weak. Again, low emission. The 75 is in, and we should be reading between 0.71 and 1.1, which should be somewhere in that area right there. Boy, just barely over the line. Barely over. It's not even in the normal. That's bad. God. Well, we're not down and out yet, folks. I still have one more 75. It's a used one and an old one that I've been keeping out in my stash because, like I said, I accumulated some of these tubes before I had my tube tester. And last one, if it doesn't work, I'm going to have to contact Gino and get some new tubes, a 6A7 and a 7A5. Remember, 0.71 to 1.1, right in there. Here goes. Gino! Well, that's it until next time, folks. I contacted Gino already, told him I needed a 6A7 and a 75. And when they come in, we will continue this saga on the next video. Until next time, this is John.